So hi, I'm Dan from Voxel8. The first thing I'm going to do is show you guys a video, but before we get to that, I'd like to see how many people have used a 3D printer before. Any hands out there? Great. How many people have seen the store on Newberry Street, the MakerBot store? You walked by that. Awesome. So we have a pretty good group on knowing what 3D printing does currently. So typical 3D printer right now is able to create really interesting geometries out of a single material, usually a plastic. At Voxel8, what we're attempting to do is add functionality to what you're printing by being able to print electronics. So what you're viewing right now is us actually embedding an IC, printing traces off of that, and creating a fully three-dimensional circuit board embedded in what we're printing. Here we're actually building a quadcopter, embedding an entire PCB board in it, printing out to the motor connections, and then building a flying drone that's coming off our printer directly. And afterwards, you can come check out the drone I brought with me today. And here's one of our engineers actually flying it around our office space. So what we're really trying to do is push the limits of 3D printing so that we're getting away from just creating basically form. If we could get in my presentation, it'd be great. Get away from form and start really adding functionality into it. So I'll run through a couple of slides here and then take your questions. So how are we able to do this? We come from a material science lab at Harvard. So effectively 3D printing has been limited by the material palette they've been able to print. People have been typically just printing plastics. We have the research and development on new materials that we're able to co-print together so you can start embedding function in what you're printing. So this is our first platform you see there on the right-hand side. It has two print heads that allow you to print in plastic, as you guys saw in the video, and our conductive ink. And it's important to know our conductive ink is about 5,000 times more conductive than any other 3D printed material on the market. And this really allows you to do interesting things. So instead of just being able to do kind of resistive inks that would allow you to do sensors, you can actually do interconnects between electrical components and actually create digital circuits inside of what you're printing. And so a question we always get is, you guys have the hardware, how do you make the parts for this? And the answer is that we've actually partnered with Autodesk, and they're coming up with a brand new design tool that allows you to basically take your CAD models, your 3D models, import them into their design environment. They have a library of electrical components that you can then drag and drop inside of what you're creating, and then wire those all up together. And then that immediately ports to our software that basically plans the tool path for our printer and prints directly out. So what types of things can you make? You saw a 3D circuit board there. We can also make kind of a more typical 2D layout. So let's say you just wanted to prototype a circuit on your desk. Something like that green circuit board there took us about 15 minutes to print. And then of course the now famous quadcopter, you can see there we have some CT scans next to it, and you can see the embedded PCB chip there, or PCB, full PCB there with the wiring harnesses coming out to the motor connections. And on the top view, you can actually see us printing in the Z direction as well, basically doing the leads up to the LED headlights. So it really frees the geometry of the electronics you're printing in there, and it kind of frees you up, allows you to bend, mold, and change your electronics around. And so this is the full platform. You effectively design in Autodesk software. You're able to print on the Voxel8 printer, and then you have your functioning device coming right directly off the printer. And here's a close-up of what we're able to do. You can kind of see the traces in there, and you can see the design file on the left and all the different layers we're printing on there. So we launched at CS. We got a lot of great press. Love you guys to check out our website, and feel free to come up and talk to me afterwards, but I'd love to take your questions now.
Is your IP really in the ink primarily?
It's in the ink.
Sell that to other printer?
It's in the ink and printing methods. We did think about just selling the ink effectively, but there is some hardware changes that you need to do. So it's not as simple as just kind of bolting on a new head onto an existing printer.
How do you imagine an electrical engineer and a mechanical engineer working together?
Yeah, that's an interesting question. So the question is, how do you envision a mechanical engineer and electrical engineer? Because you kind of need both expertise to really fully utilize this printer. And the answer is, that's something that we think people become more cross-disciplinary. Effectively, you'll probably work with your electrical engineer to design your circuit, but then you're going to need your mechanical engineer to see how it really lays things out. But you start looking at products far differently when you use this technology. No longer are you looking at kind of, all right, I know I need this much electronics, it's going to take about this much space, I'm going to have to design an enclosure that fits all this in. You can effectively fit the electronics in any form factor you want, embed them into the walls, So you're going to look at your product and see exactly what shape I needed, where do I need those sensors to best work. So it's going to take people to be a little bit cross-disciplinary there.
Is this like technology that is more targeted at individuals or for prototyping, or is it more at scaling to manufacturing?
So the question is, where is this technology targeted at? And the answer is, we're really trying to push this towards a manufacturing platform. We believe there's products out there that just aren't made today because they can't be made. They are effectively stuck in a 2D world. So this developer's kit is really targeted at getting into the hands of R&D engineers at large companies that will drive these kind of designs and innovation for new products that our platform will be able to create. We'll go to the gentleman that was right behind you.
I have two questions. Number one, what is the platform size? How big an object can you make with it? And number two, are you going to be selling to resellers that provide a service to people?
So the first question, what was the build area on the printer? For the first platform releasing, it's 4 inches by 6 inches by 4 inches. There's no real reason that couldn't get larger in the future. That's just what we picked to start out with. And then I think your second question is, are we going through resellers to actually sell the printer? The answer is currently we're pre-selling on our website in a direct model. I could see in the future us using resellers, but currently we're just doing direct because we're doing fairly limited quantities. Yeah, go ahead.
Are people going to be selling services off this possibly to end users?
We hope so. I mean, it's a platform, so we're not positive exactly all the things that are going to be used, which is one reason we wanted to get out to the market. It certainly seems possible that people would use it, take designs from other people, and create them basically for them.
We don't know if you make it for the cost.
Yeah. So for the entire platform, we're pre-selling it right now for $9,000, and that gets you both the hardware, software to design components, and to run the printer, and then also the material for your first 20 prints.
Can you give a rough idea of the consumable cost?
Yeah, so something like the quadcopter would cost you about $5 to $10 to print. So the conductive ink is expensive on a per ounce basis, but since you're just using it for electrical traces, you don't use all that much of it. So it's not particularly expensive as far as prototyping goes.
Aside from the quadcopter, what else can it print?
I mean, it's frankly limitless. You know, we've done an electromagnet, we've done a quadcopter, we've done an Arduino capable board. It's frankly anything you want, you know, and we're kind of struggling. We just got our prototype printing and we got our demos out, but frankly we're interested in people coming up to us, giving us cool demo ideas so we can print them out to start fostering that imagination, because there's countless things you can print.
Is there any data on how the inks and plastics are stable? Like, do they last a long period of time? Do they degrade over time?
So the question was, is there any kind of life testing on the inks? What I'll say is we've had an ink formulation for over 6 months that we've printed out, and it's been fine. They can degrade if left out into the open, and we'll be doing that testing going forward. But from what we've seen, and your question might also go to after printed, how do they degrade as well? And from there, we haven't seen any problems. And actually, since oftentimes they're encased in plastic, they're actually it's kind of a far better way of housing your electronics than the typical way.